What's going on, everyone? My name is Johnny Bannon, and I'm your CCNA instructor for this CCNA video series. And in this video, we're finally going to put a bow on our wireless section, or at least the lecture part of it. So in this video, we're kind of doing a culmination of everything we've learned and now putting it into practice by actually deploying a wireless LAN area network. So the first thing we're going to do is kind of go over our planning. So no matter what, whether or not you're the CCNA that's planning a small to mid-sized business, or that wireless engineer that's going to plan out an airport or a whole stadium, there is a planning phase. And there's many steps to this planning phase for a wireless engineer. There's a site survey, there's the hardware procurement, and getting into like project management, there's a lot of different steps when undertaking maybe $1 million wireless deployment across or nationwide, right? However, for the CCNA, we're just going to go over kind of the planning you want to be thinking about for your small to mid-sized business. And these are just the basics, and you can scale what I'm about to teach you into larger networks as well. Because what we're going to go over is really the switch, the technical, right? The switch configuration. We're going to go over some concepts like mapping VLANs to SSIDs. We're going to get into the initial deployment of an actual unified network, meaning the CLI configuration of an actual wireless LAN controller hardware appliance, and then accessing the GUI, activating the license, and then the basics of setting up a wireless LAN controller. So we're teaching you the bare bones of fundamentals that you can scale out. Now this isn't going to include like creating your heat maps, doing the site surveys, figuring out which channels and RF we're going to use. We're kind of not going to get into the actual RF spectrum planning. We're just getting into the actual like logical stuff, the digital, right? As opposed to the analog RF planning. That is a part of a wireless engineer's job. Don't get me wrong, don't get it twisted. But for the CCNA, I believe Cisco's whole purpose of putting in this wireless section is to get you familiar and to get you kind of on the keyboard familiarization, not the actual RF spectrum planning. So with that being said, let's jump in and go over our agenda. So the first thing we're going to go over again is the planning the wireless LAN, and that's going to be looking at a network diagram and then kind of just talking over what we have to do, right? So with anything, we want to kind of have this backwards planning mentality where we have an end goal in mind and we plan back from there. And again, this is kind of speaking to that small IT admin. If you actually want to get into project management and whether or not your IT operations takes on an agile framework and all these different project methodologies, that's not going to be in the CCNA. We're just kind of going over what a technician should be thinking about, right? And as that technician, you kind of want to go over your network diagram, see what you're going to have to configure at your layer 2, your layer 3, see what SSIDs we're going to create. Maybe go over what kind of security, basic security we're going to do. Again, that switch configuration. We're going to go over mapping VLANs to SSIDs. So essentially what we mean by this is maybe on our wired network, our distributed system, we have like the sales and the engineering VLAN on our wired network. And now expanding that into our wireless network, how do we make sure that our sales and engineering users are connecting to the correct SSID that correlates to this sales broadcast domain? So mapping VLANs to SSIDs. Again, the mapping terminology may be a little confusing. Essentially, we're saying, okay, we already made VLAN 20 on our wired network. Now, how do we make sure that users can connect to VLAN 20 via Wi-Fi? So that's going to involve our access points actually advertising different SSIDs that correlate to that different broadcast or logical networks. And then we're going to go over actually creating the wireless LAN. So this is getting into the wireless LAN controller and setting up our actual SSIDs to be advertised, our interfaces. So this is actually setting up the wireless network, right? I need to set up the sales SSID. How do I do that? How's that initial configuration done? And then we're going to go over setting security and QoS. Now, this is just going to be me on the actual wireless LAN controller GUI, clicking literally the buttons that get you there, saying, okay, if you want to set up QoS for our engineering wireless LAN, or whatever SSID, whatever wireless LAN you want, here's how you get to it. We're not going to get into the nitty gritty of the actual QoS profiles and what they do and different secure layer 2, layer 3 security on the actual wireless LAN. We're just going to show you, right? And then a part of this, creating the wireless LAN controller, is also initial setup of an actual wireless LAN controller. So this is going to be in our unified networks when we have actual hardware appliances for our wireless LAN controllers. And also even if we deploy them virtually, we're going to go over that initial setup on the CLI. So we're going to essentially clear the configuration on my 2504 wireless LAN controller. And then we're going to start from scratch with it. In our next video going over the actual lab, I'm not going to be using physical hardware or for the wireless LAN controller. I'm actually going to virtualize the wireless LAN controller in EVE-NG, and I'll show you that. And the steps are essentially the same. Whether or not you deploy that wireless LAN controller as a virtual appliance or an actual hardware appliance, the initial setup is going to be the same, and how you configure the service ports, management port, country codes, stuff like that, okay? So with that being said, let's go ahead and jump right into it. So here we kind of see the network diagram that we're going to be using for this demonstration. For all these slides going over the complete setup of a wireless LAN, this is the diagram we're going to use. And this should be on almost every one of our slides. So let's get into this. So as we can see here, we have a layer 3 switch. And it looks like this layer 3 switch is doing our switching, right? Switching our layer 2 VLANs. And also doing our routing out to the ISP. And also just doing our internal routing between all of our broadcast domains. So as you can see here, we have 3 VLANs. We got VLAN 10, 20, and 30. So our sales are going to be in VLAN 20. Our engineering department is going to be on VLAN 30. And then the wireless LAN controller and our access points are going to be on VLAN 10. So with that being said, let's go ahead and get into the actual planning of how we're going to configure this switch and why we kind of architectured it out like this. So let's get into it. So as you can see here, we decided to have 3 subnets or 3 broadcast domains. We decided to have a management subnet, and that's what I'm labeling it. And this is going to be the IP addresses or the subnet that's for all of our wireless architecture. That's going to be VLAN 10. And then you see here, like my admin laptop, I decided to make that a part of VLAN 10 as well. However, as long as there's routing between these VLANs, there's inter-VLAN routing, we could really access this wireless LAN controller from any PC and any subnet. I just decided for simplicity's sake to keep it all a part of the same subnet. Also, these access points, they technically don't have to be in the same subnet as the wireless LAN controller. As long as this access point can reach the wireless LAN controller's IP address to build that CAPWAP tunnel. And again, this is a lightweight deployment. I guess I should say that because we're using a WLC, so it's lightweight. But as long as that access point knows how to reach and can reach the wireless LAN controller's IP address, it doesn't have to be on the same subnet. Again, for simplicity's sake, I just kind of want them all in the same subnet, and this is kind of how I'm going to architecture out this small business, right? And then we see here, VLAN 20 and 30, we're going to want to create our own wireless networks for VLAN 20 and 30. So we're going to have to do that from the wireless LAN controller GUI. Now looking at the actual switch config. So because it's a layer 3 switch, what's the first thing we're going to have to do? One, we're going to have to create the actual VLANs. So that's easy. The commands, VLAN 10, 20, 30. And then we're going to have to set the ports up. So as you can see here, for all of our users, we have access ports. And for the actual access points, even though they're going to be switching traffic for VLANs 20 and 30, we can put them in access ports. Now, why is that? Because essentially this port just allows this AP connectivity to our wired network. And then when it makes that CAP-WAP tunnel down to the wireless LAN controller, the wireless LAN controller is going to be the one doing all the routing and switching for these users connecting. So at the wireless LAN controller, we'll have to create two logical interfaces. One logical interface being for the VLAN 30 subnet, and one logical interface being for the VLAN 20 subnet. And then those logical interfaces kind of act like SVIs, where for all of our wireless connections, that's how the wireless LAN controller is going to know it's part of that subnet, right? Now, there is some scenarios where the access points can be connected on truck ports, and that's when they're doing like local mode, where they allow the switching at the actual access points, even in a lightweight deployment model. But again, we're just doing the basics here. So this is how we're going to architecture it out. And then you see the trunk port here. So this wireless LAN controller is going to have a trunk port. And why is that? Well, that's because it's going to be doing kind of that, or it's going to be routing network traffic for all these different subnets. So we're going to get on this trunk link those 802.1q tags for VLAN 10, 20, and 30. So you may be asking yourself, okay, well, if this is going to be part of VLAN 10, then what do I configure on this side? And then how does this switch know that the VLAN 10 traffic coming inbound needs to be tagged with VLAN 10? In the initial configuration of this wireless LAN controller, we're going to set the 802.1q tag. Also, at this trunk port, we can do a command called switch port trunk native VLAN 10, and that's going to say on this trunk port, essentially we're just tricking it, saying, hey, tagged traffic is going to come in, and treat it as the segmented tag traffic. That's essentially what that command is saying, and that's what we're going to do so that this wireless LAN controller does have access to the VLAN 10 network, or the switch virtual interface 10 that's residing on this switch. So for this switch configuration, we pretty much covered it all. We're going to create access ports here, a trunk port here. And then another thing to note in our wireless LAN controllers that we're not going to do in this demonstration, and that's because there's a hardware limit. On an actual wireless LAN controller, you can have two interfaces that you can use to manage the wireless LAN controller. You have something called a service port, and then you have your management ports. Really, these are called distributed ports because they're the ports that connect you to the distributed network or system. But essentially, these are the regular interface connections going to the switch that are going to be doing all of our data traffic, right? This service port is a faster gigabit Ethernet that's used for out-of-band management that's on a completely different subnet than our management ports that you'll see here, that you can configure so that you always have different access or redundant access to the wireless LAN controller. However, on my 2504 wireless LAN controller, which I'm about to show you before we move on to the next slide, there is no service port. There's just a console and management ports, and that's it. So now that we kind of went over the planning here, we're going to get into the switch configuration. But before we do this, I'm going to quickly pause the video, bring my camera over to my actual gear, and then we're going to go over the gear I have for this demonstration. Okay, so as you can see here, I just set up my camera to kind of go over the little infrastructure we have. So as you can see here, I have my Cisco wireless access point. This is a 3702. And something you can kind of see, I'm going to get real close up to the camera there. I know it's backwards. I wish I could change that right now. But you see the air cap, 3702IA. That A is actually the country code. And I wish I could flip my camera's direction here so we can get a better look. But essentially, that's going to be the country code that has to match up. So there are country codes that you got to match up with these access points. And if they don't match up, then they won't actually be able to connect to your wireless LAN controller. They have to have the same country code. Just a little tip for you. Well, really not a tip, a rule. And then, as we see here, we have our Cisco Catalyst 3560 switch. This is just a simple 8-port switch, great for labs. As you can see here, it's all fast Ethernet right down in here. And then we have gigabit Ethernet right here. And I noticed in this lab, this is where I had to actually connect from switch to wireless LAN controller up here, or the connection wouldn't work. I don't know why. I think something, I mean, obviously something to do with duplex and speed, I'm assuming, or more or less speed, but it just wouldn't connect. So this wireless LAN controller, this 2504 wireless LAN controller, let me scoot this up. As you can see here, there's a couple ports on here that we're going to go over. So this first port is going to be the console port right here. This is going to be where we actually get in to do CLI, just like any other console port in a switch or router. It's going to do the exact same thing. It's going to give us CLI access. And then we have these 4 ports here. These are our distributed system ports, or our management ports. So when we actually do the initial CLI configuration of this wireless LAN controller, we're only going to get options to configure ports 1 through 4. Whereas if we deployed a different wireless LAN controller that had that service port or that a redundancy port for high availability and that failover, during the initial CLI configuration, we'd also get options to configure that as well. So I'll kind of, when that happens, I will, sorry about that. When that happens, on the CLI where it tells us to configure the management port, I'll take a pause and say, okay, next would be our service port. It had to be a different IP address and all that. So I'll make sure to make note of it. But the reason we're using this wireless LAN controller is because it's very common. You go on eBay, you look up CCNA wireless lab or wireless lab Cisco. You're typically going to see these. They're end of life. They were used forever, for a long time, and they're great for practice. You can reboot them, clear the configuration, mess them up, fix them, all you'd like. All right, so with that being said, now I'm going to pause the video again and let's get back to our lecture. Okay, so now let's get back into our lecture. So now we're going to go over the actual switch configuration. So the first thing we're going to do, and there's no particular order, but again, in the previous slide, before we actually went over the actual hardware, we said we had to make access ports, we have to configure these different VLANs, and then we have to set trunk ports and again access ports. So that's what this slide's going over. So you can see here, kind of going back to our layer 2 basics, we got to create the VLANs, we got to set the access ports, and then we're going to set the trunk port to the wireless LAN controller. And you see here a couple commands. This one not really needed, the trunk allow, just some basic security. But this trunk native VLAN 10 is going to be used because during the initial configuration of the wireless LAN controller, it's going to be tagging all of its traffic leaving the wireless LAN controller through those management ports with VLAN 10. So this port still needs to be able to recognize those 802.1q tags and tag right with VLAN 10, even though it's a trunk port. So one thing we're going to do here as we go through the slides is actually go ahead and do these configurations real time. So what I'm going to do here is open up Secure CRT. And currently, I am consoled into my switch. Now, the great thing with Secure CRT here, if you come to Session Manager, come to New Session, Serial, Next. What's great is it already picks the COM port that you're supposed to be using. If you're on an older computer or an older version of Secure CRT where it doesn't automatically pick the right COM port, what you'd have to do is come to your device manager, come down here to ports, and look at what COM number it is, then input that into your whatever terminal emulation program you need. And then, of course, baud rate's going to be the standard at 9600. And now let's get into our switch. Okay, so it looks like there might be some configuration previously on here. So Wi-Fi lab. So if we type in show VLAN brief real quick, yeah, it looks like I already did configuration. But let's just go through it again. And I'm going to zoom in here for you guys. All right, awesome. So the first thing we're going to do again is create these VLANs. So real simple, you should already know how to do this. But for anyone viewing this that isn't going in order, this is going to be really for you. If you're not watching all of our CCNA videos, you know, complete setup. So next, after we created our VLANs, we're going to set our access ports. So if we kind of zoom this out, this is going to show us all the access ports that we need to configure. So access ports 7, 6, and 5 are all going to be in VLAN 10. Interface range, fast Ethernet 5 through 7. We're going to do switch port mode access. Switch port access VLAN 10. And then interface fast Ethernet 01 is switch port mode access. Switch port access VLAN 30. Then interface VLAN or interface fast Ethernet 02 is going to be switch port mode access. Switch port access VLAN 20. So just assigning the correct VLANs, right? An important thing to make this lab work is your access ports being on the correct VLAN. And then next, we're going to configure our trunk ports. So our trunk port's actually going to be gig 01. Remember I was telling you we need gig ports on our actual, this little lab environment I have here for the wireless LAN controller and switch to talk. And just to verify that it is gig 01, just a quick show IP interface brief. So we're going to come here, we're going to do switch port, trunk, encapsulation.1q. So just making a basic trunk. Then we're going to do switch port native VLAN 10. Then switch port trunk allowed VLANs 1, 10, 20, and 30. All right. So that's going to be it for this. Now let's move on to the more advanced switch settings or configuration. So now what we're going to have to do is actually create the routing for that layer 3 switch. So we're going to create interface VLAN 10, 20, and 30, which is going to do the inter VLAN routing for all of our VLANs and subnets. And then, check this out, guys. We have to create a DHCP server for all of our VLANs. What's unique for VLAN 10 is we need to put this option 43 IP address in so that when these access points boot up and they do their door request for DHCP, they're going to get that option 43, which points them to our wireless LAN controller's IP address. Very important. And then we need to exclude that wireless LAN controller's IP from the pool so it doesn't get allocated out. So let's go ahead and do that. So let me get rid of some of this pen on here. Let's go ahead and create our SVIs. So we're going to go interface VLAN 10, description, management SVI, go IP address 192.168.10.1 and then a /24. No shut. Going to do this for interface VLAN 10 as well. IP address 192.168.20.1 /24. No shut. Give it a description. You get going quick through this, guys, because this is not, the switch configuration is a part of your wireless LAN studies and deployments, but if you're watching these videos in order, we already know how to do this, right? We're just creating SVIs and setting IP addresses on them, using the first usable as a default gateway, and putting a good description because we're good network engineers that like decent documentation, right? And then we're going to create our DHCP pools. So the first one I'm going to make is just going to be for the sales. Going to give it network 20.0/24. Default router 192.168.20.1. Some DNS servers, and then we're going to call it a day. And then we're going to do the same thing for VLAN 30, which is our engineering department. So we're going to do 30.1. The network is 192.168.30.0/24. Give it some DNS servers. And then boom, call it a day. All right, next, the very important DCP pool, which is going to be for our Wi-Fi network. And we're going to have to give this a network of 192.168.10.0/24. So I already created this pool prior. So let me go ahead and actually just get rid of it so you guys can see the full configuration. So I called it WAPs before. So I'm going to get rid of that. And then go back into my new one that I'm going to create so I can go through the entire steps with you. And really nothing changes except putting in that option 43 address, which again is going to be one of the methods that the access points use to create that initial connection, that CAP/WAP control connection to the wireless LAN controller to receive its configuration. Okay, so now we're going to put that option 43 IP 192.168.10.100. And then we're going to want to exclude that address from the pool because it's a static, right? So we don't want any conflicts. And then the last thing we're going to do, which is on this slide, is set the timing. So our access points in our wireless LAN controller, they have to have the same country code, and they also have to have the same timing, or they're not going to connect or create that CAP/WAP tunnel fully and download its configuration. So for example, another kind of example of this, guys, is the access points I have right now. My wireless LAN controller doesn't have the right version, so they can't connect even though they can talk to each other. Same with the timing, same with that country code. The access points may be able to discover the wireless LAN controller, but if all these parameters aren't in place, kind of like a routing protocol, you know, with like K values in Edge ERP or the hello hold timers in OSPF, if these things don't match or aren't parameters that are good to go, right? Like with timing, with the country code, making sure that my wireless LAN controller version can actually connect to certain access points, we're never going to come up. And one of the things we can do from the switch is we can make this the actual timing source. So what we'll do here is do clock set, and we just have to make sure all the timing matches. So we're going to make sure that the wireless LAN controller uses the switch as the NTP source so that its timing matches, and then when it connects to the access points are going to get its timing from the WLC, which is getting it from the switch, so we're all synchronized. We're just going to make this 1 Jan 2023. Then the key command here is going to be NTP master. Yeah, these older switches, they don't have that NTP master command. I can't remember what these old ones would be. We're just going to leave that alone. But just know that for a real-world deployment, you're going to need to make this. You got to just synchronize timing, essentially. That's all we have to do. As long as I set the clock here and I tell that wireless LAN controller to synchronize to the switch, it should, okay? Even without making this NTP master. So we're just going to skip that step for now, but on the slides, you're going to see that it is there. Okay, now we're going to stop this video, and then on our next video, we're going to get into the actual wireless LAN controller initial configuration. So stay tuned, as this is where we're going to go over the different ports on the wireless LAN controller, and then we're going to go into the initial configuration. It's going to be a great time.